Okay, so number 16 on the cumulative review for chapter 3, pre-calculus 30. This question says determine the x-intercepts and the y-intercept of the graphs of each polynomial function, then sketch the graph. Okay, so we need to find the intercepts and sketch. So let's focus on the y-intercept first. The y is really easy. It's the constant term. Okay, so the y-intercept is down here at negative 18. Okay, that's a point that is on the graph for sure. It has to pass through there because it's the constant. Why do I know that? Because when you let x equal 0, that's 0 plus 0 plus 0 minus 18. That's 0 minus 18. That's your intercept. Got it? So that's easy. Now the x-intercepts, this is where we have to factor. Okay, so this is where the process begins, where you have to start to choose factors or possible factors that are, remember the a value has to be a factor of negative 18. So x minus 1, x plus 1, x minus 2, x plus 2, 3, 6, 9, 18, those ones. Good idea to start with the smaller numbers first, okay? It's usually, because if you can pick one of these, like get one of these factored out right away, then you're going to have a quadratic, right? This bumps down to a quadratic. Probably you're going to be able to factor that by sight. So we just need to get one of these factored out of here first. So if we remember our factor theorem, let's check this one right here. So that's p of 1, right? So if I try x equals 1 in here, if the remainder is 0, or if the answer when I evaluate is 0, then x minus 1 is a factor. Let's just try it out. We've got negative 1 plus 2 plus 9 minus 18. That doesn't look very good. This 18 is pretty big, and those other ones don't add up to positive 18. So it doesn't look like that one's going to work. What about, let's try a 2. Let's try a 2. We need some bigger numbers in here, right? Where these x's are, we need some bigger numbers because we got to battle with this 18 here. So let's try a 2. Put a 2 in there. That's going to be negative 8, right? 2 cubed is 8. Plus 2 times 4, right, is 8. And then plus 9 times 2 is 18. Ooh, this looks really good. Those cancel off, and these cancel off. Awesome. Okay, so that means if I put a positive 2 in there, that means this should be a factor right here. Okay, that's our winner. And from there, what we're going to do is we're going to probably do some synthetic division, I would say. Probably be the easiest. So let's divide this polynomial by x minus 2. So I put the a value, positive 2 there. I put the coefficients all along the top row, making sure I've got the coefficients for each descending term here. So 3, 2, 1, 0. So negative 1, 2, 9, and negative 18. This number that I end with here should be 0. So I'm going to anticipate that if I've done everything else correctly. So synthetic division, we drop down. This number, we multiply. We add. Do it again. Multiply, add, multiply, add. Awesome. Okay, so that's synthetic division. Went over that pretty quick, but we've been over that a number of times. So look up that video, ask some more questions about that if you need to. That's synthetic division. So that means that I have this, x minus 2 as a factor. Don't forget about that. But I also have now, this was a cubed, so this is squared, or negative x squared. And that's plus 0x plus 9. Okay. Those are my factors now. All right. So let's rewrite that. X minus 2, negative x squared plus 9. Now, you might say, okay, I don't know if I can factor this. That looks like a difference of squares, but it's not quite a difference of squares. Well, technically it is, because you could switch around 9 and x squared, and then it would be 9 minus x squared, which is totally a difference of squares. So you could do it that way. If you don't like doing it this way, what also you could do is factor a negative out, and that would change these signs. You see this? And now you have the difference of squares that looks just like you're used to. Either way is going to work. Either way is going to work. So let's try this. X minus 2 with a negative out front, negative 1, right? And this is going to be x plus 3 times x minus 3. Okay? Now, when we multiply all those together, we should get our polynomial, our original polynomial. I won't do that right now, but I'll just stop and check check my algebra here. Okay, so what this gives us now is this gives us, this is the f of x. And so I can look at these factors now and I can start to piece together my graph. So over here on the right, I know that I have a y-intercept of negative 18. I also know that I have a y-intercept of 2. So I got a point there. I have a y-intercept of, here's positive 3 as well. 3. And I have a intercept of negative 3. Okay? I know I have those. I'm going to just zoom in this graph a little bit because we're going to need a little bit more space, I think. Okay? So I've got the x-intercepts now. Okay, x-intercepts. So x equals negative 3, 2, and 3. Those are the x-intercepts. Or more specifically, you'd write them as actual points, which that's more proper. Those are your x-intercepts. And now I need to sketch. So what else do I need for sketching? I need to find out the end behavior. Okay. I also need to figure out the zero behavior. So let's check the end behavior. This is degree 3. So that means it either goes something like this from 3 to 1, or it comes down like this, right? From 2 to 4. Because this is negative, it's definitely the 2 to 4 one. Okay, it comes down left to right because that's negative. So my end behavior is over here somewhere. Okay, and then over here. That's what I usually do, just kind of the ends of the arrows. You can adjust those later if you want. And of course, now what we want to do is we want to consider what happens here. Remember, this is what happens if we have, let's just say if we have an intercept here. If the multiplicity, remember that's what we're looking for. We're looking for actually the exponents on all the factors. If the exponent is a 1, it's simply a cross, straight line cross. If the exponent is a 3, it's tangent to and crosses, so it flattens out a little bit there. Okay, it's this looking. If we have a 2, then it kind of touches and bounces back up. And if it's a 4 or 6 or even but larger, it comes tangent to a little bit earlier and then stays kind of more a flatter bottom. Okay, that's the difference there. All right, so with our multiplicities here, I have 1, 1, 1. Awesome. So what that means is that this should simply cross. Now we're going to have to come down and hit this negative 18. What we don't know is sort of where it comes down, how far it comes down. But we know that it does come down at least to 18. And I would suggest that because the midpoint of these two intercepts is over here, that's probably where your minimum is going to be. So it's going to be something like, this. Okay? It's probably going to be somewhat symmetrical, so I would guess that. So it's got to come through this negative 18. And then it's got to come up here, and this isn't to scale or very neat, of course, like this, and then down. And then, of course, that follows our end behavior there. Okay? So your graph kind of looks something like this. You don't know how high this goes. You don't know how low this goes. But you do know this intercept, this one, and this intercept as well. Okay? So as best you can, and I guess this gets pretty messy there on my tablet, but this is sort of what you're looking at. Okay? So I think that covers everything for that question. Was there anything that I missed or anything that you'd like to ask me about further about this question, any of this process? You're good now? Okay. Thanks for the question. Anybody else have any questions about this? No? What was that? Sorry.